In these notes, we are going to go over 8.3 practice number 1. I'm sorry, they're not notes, these are practice. So in this video, we're going to go over practice number 1, quadratic functions in standard form. So if you look, it says standard form is y equals ax squared plus bx, and it should say plus c, but this program is showing you how important the c value is. So it asks you to move the vertex anywhere. If you notice, look at the y-intercept. Now it's 0, 18.6, and look at what happens to the number in place of c. So hopefully what you guys are noticing is that whenever you move the parabola, the y-intercept changes. It's where it touches the y-axis. And it changes the c value. So here this graph is 0, 10.5 for the y-intercept. Look at where the c value is. It's 10.5. So the connection is when you have standard form of a quadratic function, the c value is the y-intercept. Now this is going to come in handy when we actually do projectile motion, which is like a physics application. When you throw an object in the air, your c value is where you started the object's throw. It's actually pretty cool. So here we have the a value, which is -2, the b value is 4, and then -3. So our c value is 0, -3. Y-intercept is always 0, -3. Well, the x is always 0 because you don't move left or right any. So then this would be 0, 7. All right, so for this one, what we're going to be doing, we want to identify the a value, which is 3 because it's next to x squared. The b value is 12 because it's next to x. And now our c is -5. So we can find the y-intercept right away just by looking. That will be the easiest problem that we ask you. Make sure you type it in correctly. All right, cool, we got it. Now we're going to use the x equals, which is, remember, the axis of symmetry. The opposite of b over 2 times our a value. So all we did was plug in our a on the bottom and our b on top. The negative and the 2 stay because that is part of the equation. So then -12 divided by 2 times 3 gets you -2. So my x value is -2. Let's double check this. All right, cool. So then we can move on. And you can check it here as well. Okay. Now to get the y value of the vertex, we want to plug in the -2 wherever you see an x value. Now we're looking at this equation up here. Do not forget the square. That is the most common mistake. And do not forget the parentheses. That's the number 2 common mistake. And then you just plug and chug. Use the calculator all at once. Don't forget the square. Don't forget the parentheses. Before you hit enter, make sure you wrote it right. All right, -17. So let's confirm. All right, fantastic. So the vertex is the x and y together, or what we used to call the h and k. So -2, -17. Awesome, fantastic. Now we're going to just do this for the rest of the slides. Y-intercept, easiest thing that you can do. It is just the c value, so it's going to be 0 for your x always because you don't move left or right. But in this case, we do move +3 because that's what our c value is. We got to be careful here. A is actually a 1. It's the number in front. Here, B is a -4. C value is a 3. So we want to use x equals the opposite of -4 over 2 times our A value. So we're going to use that -4, and we're going to use that 1. Remember, this negative sign and this 2 come from the problem. So that will always be there. I'm going to use the calculator. Make sure you have the 2 negatives. So then we have x equals 2. So that is our axis of symmetry. It's our vertical line that cuts down, and it's also our x value. Now, how do we find our k or our y value? We plug it in. We use the original equation, and wherever you see an x value, you're going to plug in that 2. Even though it's a positive 2, I highly recommend you still use parentheses. It is an amazing habit to get into, because the calculator already knows that parentheses mean multiplying when you have it next to another number. It kind of takes the thinking game, do you need them or not, out. So my calculator outputted y equals -1. So we know we're right. So then 2 comma -1. And there we go. Now the whole point of doing this is eventually we're going to have a graph, and you're going to be able to know that the y-intercept is 3 because we said it was 3, and then we said the vertex was 2 comma -1. And remember, our A value is positive, so that means it's concave up. So then I could sketch a rough graph of my parabola. So eventually that's what we're going to be doing. Okay, we want to be careful here. Our A value is already negative. We're going to got to remember that negative sign. Our B value is positive, and our C value is -10. Let me make sure I have enough room. There we go. All right, so my y-intercept is my C value, so it's 0 comma -10. All right, please ignore these two things. I have to switch them when I'm done with the video. So check your y-intercept. That was y-intercept. And then this will be your AOS. So that's my fault. All right, so then we're going to get into the opposite of B, which is -16, because that's our x value, all over 2 times -2. Use the calculator. So we have -16 divided by 2 times -2. So our x value is going to be a +4. And then we just plug it in. And you can confirm that, x equals 4. Awesome. So then plug that in. Once again, use parentheses. And then you're going to get y equals 22. And yeah, that's a big number, but parabolas are anywhere on the graph, so it does not matter. All right, let's check the vertex. Awesome, fantastic. We know that we did it correctly. All right, this one's a little tricky. I recommend writing it out. A is next to your x squared. B is next to your x. Since there is no x, your B is 0. and then your C is 7. So I'm going to go ahead and do my y-intercept real quick. I'm going to check it. All right, fantastic. And then I'm just going to plug it in. And I understand that some of you are like, well, 0 can't be positive or negative. The negative just comes from there. So just get in the habit of writing it. It's fine. The opposite of 0 over 2 times 5 is always going to be 0. Whenever you have 0 on top, that's what happens to it. And then you're going to plug that 0 into wherever you see an x, which in this case is just one of them. So 5, parentheses 0, squared, which is silly because 0 times 0 is 0. And then don't forget the plus 7. So your y is actually going to be 7. So the axis of symmetry is your x value, so x equals 0. Fantastic. Your h value or your k value is 0. Your y is 0. Put that together for your vertex. And we know we did it right. All right, so the last part, these are just very similar to the notes that we've done. Now we're asking you to plug in the h and the k into vertex form. Just to show you that standard form and vertex form, even though they look different, will get you the same graph if you graph them. All right, in slide number 9, you're going to do exactly the same thing that you did in the other slides. Since there is no C value, it's 0, 0 for your y-intercept. I highly recommend you write the A value, which is -6, the B value, which is -12, and then since there is no C value, it's 0. Now, it's going to be x equals the opposite of b over 2a. So negative, and then the -12 over 2 times -6. Now, if you put that into the calculator, you're going to get 12 over -12, which is going to be a -1. And you can check that in the calculator or in the check values. Once you get the x value, you're going to plug it into the original equation. Now make sure that you use parentheses. Make sure you use the calculator. So if you use the calculator, you're going to get a +6, which is y equals 6. And then that gives you the k value of the vertex. So the vertex of this line will be -1, 6. Now the new part for this slide is plugging it into the vertex form. We already found out our A value from before. It's A equals -6. And then x minus, which our h value is -1. And then we're going to square -12. I'm sorry, our k value is going to be a +6. Sorry, it should be a +6. So our final equation will have our a value minus a negative is really a positive, and then the +6 because that's our k value. Now the whole point we're doing this is to show you that standard form and vertex form will produce the same graph. It just looks different. So now I know my vertex, I also know my y-intercept, and then I know my a value is negative, so it would be concave down, pointing down. So I could technically sketch this. All right, in slide number 10, we're going to do the same thing. Our C value is -3. So if I write my a value, it's next to x squared, write my b value, which is next to the x, my c value, which I already identified as negative 3. Opposite of negative 8 over 2 times negative 4. If I use the calculator for that, then put two negatives side by side. 2 times negative 4. It's going to get you negative 1. Now I'm going to plug that into the original equation. And then I'm going to use the calculator to help me too. I'm just retyping what I just wrote. So the calculator will give me the output of y equals 1. So my vertex would be negative 1 and 1. Negative 1 comma 1. And then what we would do next, we want it in vertex form. So all I'm doing is replacing the h, the k, and the a. So my a value we said was negative 4. My k value we said was negative 1. And then my h value is negative 1, my k value is positive 1. So then all you need to remember for this is that a negative and negative make a positive. So if you put that equation into the last spot, and you can always try this on Desmos, just like regular Desmos graphing. If you put these two equations in the same graphing, they're going to overlap. And you know you did it right if they do overlap.